Governments from Singapore to Denver are using IoT technologies to create safer, cleaner, and more efficient metropolises.
By 2025, there will be 26 smart cities globally, according to one prediction. The first step in these progressively more interactive metropolitan areas was taken a few years ago with the smart grid, which makes the electrical system built in the 1890s more modern and intelligent. Two keys to the smart grid are two-way communication between the utility and customers and sensing along the transmission lines. These design elements will play a big role in the next phase of smart cities. Officials are aiming to use IoT to remotely monitor the conditions of roads, bridges, buildings, and other sites. Gunfire detection technology will help law enforcement know where a shooting occurred and react faster to protect citizens.
Bringing this level of interactivity will require chipsets, modules, and devices that utilize a variety of wireless technologies.
To ensure these devices work in the crowded RF spectrum associated with smart cities, engineers need to validate their designs. One instrument to help in this area is a signal analyzer, such as the MS2830A from Anritsu. The MS2830A supports all key wireless technologies for IoT applications and has predefined measurement templates to simplify setting up standard compliant measurements and modulation analysis. Key measurements such as adjacent channel leakage power and spectrum emission masks can be made easily with the MS2830A. While ICs, sensors, and modules will serve as the brains to these smart cities, the central nervous system will be high-speed optical networks. Fiber is currently used in smart grids because it is robust and not susceptible to electromagnetic disturbances or capacity constraints. Smart cities will need networks that have high bandwidth, wide coverage, and can handle massive data. That is why the core of many smart city communication systems will integrate passive optical networks, Ethernet, and SDH, so they can meet the needs of today and tomorrow. To properly install and maintain these networks, field technicians and engineers need equipment that is easy to use and can conduct all necessary measurements. Anritsu delivers here as well. The all-in-one network master transport testers support R&D, manufacturing, installation, and maintenance tests of network and transport equipment operating at bit rates from 1.5 megabits per second to 100 gigabits per second. For testing fiber in the ground, the Access Master and MT9090A are complete fiber test tools that combine an OTDR, light source, power meter, and a unique fiber visualizer one-button fault location function. All these fiber field test solutions from Anritsu are compact and durable. They also have intuitive interfaces and built-in measurements that can be made using only a few keys, helping simplify the verification process.
That completes our primer on testing smart city technologies.
Learn more by visiting www.anritsu.com.